Alright, so the first thing you need to do is set up your new project, create a main.lua file, and then we're going to download these four other Lua files that are available on the GitHub page. So you'll want bump.lua, you'll want gamera.lua, you'll want util.lua, and v2.lua. So just go to the page with it, hit raw, and then hit save as. And then in your project directory, navigate to your project directory and just save it as the .lua file. You want to make sure you have the .lua extension. Once you've done that, go into your main.lua file, and then we're going to require these libraries. So all we need for now is bump, because we're just going to be creating a level with physics objects in it. And this is just going to be static physics objects for now. So like basically what we're going to do is we're going to have a level table that we can add elements to, and it'll automatically add them to the physics world that gets simulated by bump, and so we don't have to ever actually worry about physics, at least with standard static level. So the way that we're going to do this, we have to require bump. So we've got bump, and we're going to create a new world, which is bump's way of, this is the way we access the physics world in bump. We just call functions on the world variable. I'm just going to make this local. I'm just going to create my standard skeleton. I'm just going to set the background color to gray. Nothing in our draw function for now. Will be soon. Nothing in our update function for now. Okay, so the first thing I'm going to do is I'm going to define this level as a table, and inside it's going to have another table called elements. So you can add elements to the level, and these static objects will be drawn. They'll automatically be drawn for us. They'll automatically be simulated in the physics for us. So let's create our level add element function. We're just going to take rectangle coordinates, an x, y, width, and a height, and the object will just be an empty table. We're going to have some stuff inside soon, but not for now. It's just going to be an empty table at the moment. Then we're going to add this element to the world. So that's x, y, width, and height here. So I could be tracking the x, y, width, and height inside the table itself, but there's no real need to, because bump already simulates the rectangle position, right? It has to store the rectangle position to be able to do physics calculations, and its API actually allows us to get that rectangle with the with the world get rect, and then we pass it the item, and it'll give us our x, y, width, and height. So there's no need to actually store that inside T. It's already tracked by bump. The only thing we do have to track is we have to make sure that we insert T into our elements table. So since we're in level already, self is defined as level, and then we just add that to the elements. We're also going to have a level.draw function, which will just draw a rectangle for every object right now. So for we don't care about the key, we just want the value in pairs self elements do, and we want to draw a rectangle for each of these. And then here's the trick. We say get rect, and we want pass v. So v in our case is going to just be this table that we create here. We pass it, and then we have it in our elements. So it's being tracked by both our level and by the physics world. And then we're just going through everything in our level, and we're going to say, hey, physics world, can we have the rectangle for this, please? And it'll give us our x, y, width, and height, and then we can just pass that directly to the rectangle function. So all we have to do to draw this now is we're going to say level draw, and our draw will be done for us automatically. We don't have to ever actually we don't ever have to worry about drawing each element individually. It'll be done for us in one fell swoop. So if we run this right now, oops, I did something wrong here, hang on. main Lua line 3. It's just bump.new world, not bump::new world. Doesn't need access to that. Oops. My bad. So just replace that colon with a dot and it'll work. And it just gives us a blank screen, which is exactly what we want because we didn't add anything to the level yet. So let's actually do that. So in our load function, let's say level add elem, and we're going to pass it an x, a y, a width, and a height. So I'm just going to make a medium-sized box in the middle of the level. So when we run this, oops. Oh, I inserted the wrong direction. You want to self.elems insert t. Sorry. So just flip those two because that was backwards. And then we get the box being drawn on screen, which is just amazing. I mean, that's some serious cutting-edge technology right there. What we want to do here is we want to actually demonstrate that the physics are doing something. So what I'm going to do is first, I'm actually going to just return t so we can have access to this object if we want to move it around. So I'm going to set the x position to 0 just so it goes up against the wall, and this will be like our floor. Right? Let me move it down more actually to like 500. There you go. And so now it's just in the corner. And then we're going to create a smaller box. 0, 10, 10, 10. So 0, 10 for y, x width and height is 10. So it's a small box, and we're going to actually access this box. So in our update function, we're going to say box move, world move box to an x position and a y position. So I'm going to move it to, let's say 30, 30, right? And this is amazing. I mean, it moved it from here to here. That's just stupendous. But what we actually want it to do is we want it to move every clock tick in the game. We want it to fall or move sideways or something. So the way that we're going to do this is we're actually just going to say get the xy width and height from the rectangle. So x, y, we don't care about the width and height actually. And we're going to pass a box. So this will give us our box's x, y, width, and height. And then we're going to actually move the box to its x position plus 1 and its y position plus 10. So this means it'll move very, very slowly to the right and very fast downwards. So like it's gravity or something. As you can see, our physics simulation gets done directly for us. Actually, let me make this a little bit bigger. And height 20. So you just can see it a bit better. So, I mean, our physics are simulated for us without even having to do anything else. All we have to say is when we move the object, just world move, and bump does all the simulation for us, and it prevents us from like phasing through walls. And this is a really nice. Bump is a fun little physics library. I like it. I like it for prototyping. It's not very full featured if you want to do advanced physics simulations. But so much of the time people are writing platformers and stuff that using something like complex like Box 2D, which is built into Love, is complete overkill. And it ends up actually making the game buggier and less fun to play because platformers don't use realistic physics. They use fake stuff. So we get this for free just by integrating with Bump's physics world. And we don't even have to worry about doing much else. So there are a few minor tweaks I'm going to make to this code to make it a little bit more flexible later on. So the first thing I'm going to do is we're going to actually allow the draw code to be defined by each object when we create it. So when we add an element, we're going to pass it a draw lambda. Do I want to do that here actually? Yes, I do. And then we're going to say draw equals draw lambda. So draw lambda, lambda is just a fancy name for a function that doesn't have a name. So it's called an anonymous function. So if you hear anonymous function or lambda, they're completely interchangeable. So draw, we're just going to say draw equals draw lambda. So we're creating a function called draw inside our new element called draw lambda. Called draw, and then it'll be referencing whatever we pass for draw lambda. So in our draw function then, we won't be drawing a rectangle, we'll be calling that object's draw function. So vDraw, and then it'll pass, the colon means we'll pass self. So draw will be able to access v. And actually, we're going to also pass the x, y, width, and height for our object, just because it's a little bit easier that way. It's more clear what's going on, because otherwise we're going to have to call this code. We're going to have to call this code anyway, so even if it's inside, it's just more clear that we're passing it on the outside, and that's what's going on. So this will pass, this is what this is doing is it'll pass to the function that we define. It'll be passing self, x, y, width, and height. And then when we actually add our element, we're going to be creating a function, self, x, y, width, and height, and then end, and this is our box. And for now we're just going to love.graphics.rectangle, so it's the exact same as it was before. So we're going to make it a line for now, x, y, width, and height. And we need to make sure we do the same thing for our first object, which is the floor thing. So we just copy this. I'm just going to copy and paste it for now. So big whoop, why are we even doing this? I mean, it just makes more code, which is not fun. If we play it right now, it does the exact same thing as it did before. But the cool thing with this is it gives us a lot more flexibility with how we draw the level. So what we can actually do now is, let's say we set the color to red. Green and blue will be 0 for that. So the floor will be red. And the player will be green. And when we run this, oh my gosh, that's a horrifying color. I can't do it. I can't do that. I need some other color. Yes, yellow, perfect. We've got a yellow floor and a green player. And the reason we're doing this, well, this isn't going to be the player. We're eventually going to have some other stuff for that. But the nice thing, the reason we're defining these things outside is it gives us, each draw object knows how to draw itself. So this may be a bit confusing. And I'm probably going to actually revamp the way this is done. I think it would be better if it was done outside and we pass the object in with its draw function. And I will eventually be doing that. But for now, this is just kind of prototype code. It's kind of hacky. It's not going to be very pretty. But like this introduction of anonymous functions is kind of useful because you can just create things. You can create functions on the fly. Then you can just, which is kind of nice. So we can we're defining what this draw lambda is inside the function call, which looks kind of confusing, but it keeps all the code together that's related, which makes it easy to copy and paste around if we need to do that. So I mean, we can just create more box and set its position to -10, and then we'll actually have it move to the right faster so it can iterate. Can collide with the other one. And eventually we're going to have our own update functions too for that we define in our each object will know how to update itself. Whoops, I did something wrong. Oh, I referenced the wrong box. We need box 2 there. And you see they interact with each other. So we get all this, we get all our physics code, all our physics simulation done for free. All we have to do is move our objects around, and eventually we're going to be pulling each object out and giving it an update function itself, and then we'll just loop through every value in the level and tell it to update itself. So that may be a little bit confusing. If it's still confusing you, let me know in the comments and I'll try to clear it up a bit more. But this is a really flexible scheme that allows us to build out the game without ever having to write the boilerplate love.draw and call the draw function on each individual table that we create for each new object. We just add it to the level and it knows how to draw itself. So yeah, that's all I have for this video. In the next one, we're gonna actually be creating the player, and we'll be fiddling around with some of the physics for that, which is kind of fun because this is gonna be a platformer, so it's fun to have some nice player movement implemented. So thank you very much for watching. I hope this video was helpful to you. Make sure to like, favorite, and subscribe. If you want to help support the channel, I've opened up a Patreon page, either now or will be next week, and I'll be probably making a video on that. So if you want to help support the channel and help me make videos, Patreon is the way to go. So yeah, thanks for watching, and if you have any issues, make sure to comment and I'll try to help you out. As always, this code is available on GitHub. I'll have a link in the description, and links for everything else as well.